This video is on inverse operations. An inverse operation is an operation that reverses the effect of another operation. Probably the one you're most familiar with is addition and subtraction. They are inverses of each other because addition undoes subtraction and subtraction undoes addition. Here's an example. If I have the equation x minus 7 equals 12, and I want to get x all by itself on one side of the equal sign, I can undo this minus 7 by doing a plus 7 to each side, because the plus 7 undoes the minus 7. Here's what it would look like in equation. So I have x minus 7 equals 12. When I do a plus 7 on each side, these two undo each other, basically become a 0. So I have x is equal to 12 plus 7, or x is equal to 19. Multiplication and division are also inverses of each other. Dividing by 5 undoes the operation of multiplying by 5. And here's an example of that. If I have 5x equals 35, and I want to undo that 5 times x, I can divide both sides by 5. So in this case, 5 divided by 5, those are going to undo each other, basically give me a 1. And then I have x equals 35 divided by 5, which is 7. Note also that reciprocals are inverses of each other. Recall that a reciprocal is basically a fraction flipped. So 4/3, the reciprocal of that would be 3/4. So dividing by 1/5 is the same thing as multiplying by 5. Here's an example of that. I can undo times 1/5, as I have in this equation here, 1/5 times x equals 3. I can undo that by multiplying by 5 on each side, which is the same as dividing by 1/5. It's a little, if I were to divide both sides of this by 1/5, the 3 divided by 1/5 just looks a little strange. So instead I'm going to multiply both sides by 5. 5 times 1/5 is 1. They undo each other. So then I have x equals 3 times 5, or x equals 15. And squares and square roots are also inverses of each other. Squaring both sides undoes a square root, and taking the square root of both sides undoes a square. So here's an example. So the square root of x equals 4. If I want to get the x all by itself, I have to get rid of that square root sign. So if I square both sides, squaring and square rooting undo each other. So then I have x equals 4 squared, or 16. If I have x squared equals 49, and I want to get rid of that squared on the x, I'm going to take the square root of both sides, because the square root undoes the square. So then I'll have x equals the square root of 49, or x equals 7. Here's a couple examples. I think I can fit all 3 of them on the screen there. So stop the video right now and work these 3 examples in your math journal, and then we'll come back together in a minute and see if you got the right answer. Okay, number 1 says, in the equation 2.4x equals 16, which operation with which number would you have to do to get x all by itself? Okay, so I have the equation. Oops. Okay, now it's working. So I have the equation 2.4x equals 16. So x is being multiplied by 2.4x. So I would have to divide both sides by 2.4. Okay, so actually let's go ahead and write the answer here. I'd have to divide by 2.4 because x is being multiplied by 2.4. And if I were to continue solving this, 16 divided by 2.4 is 20 over 3, or 6.6 repeating. Second example here says, in the equation 7/8 x equals 3, again, which operation with which number would you have to do to get x all by itself? Since x is being multiplied by 7/8, I don't really want to divide by 7/8. I would rather multiply by the reciprocal of that, which is 8 over 7. So notice that when I do that, when I multiply both sides by 8 over 7, these undo each other because basically the 8's cancel out, the 7's cancel out, and I have x is equal to 24 over 7. And our last problem here says, in the equation the square root of 2x, and notice the 2x is all completely underneath the square root sign, equals 5. Again, which operations with which numbers, in what order would you have to do to get x all by itself? Well, since 2 is being multiplied by x, and then we're taking the square root of it, I really have to kind of undo that backwards. So my first step is going to be to square both sides, and I would do that like this. Okay, and the square and the square root undo each other, so that just leaves me with 2x. Oops. Okay, which is 25. And then I would have to divide both sides by 2. Because the 2 multiplying by 2 and dividing by 2 undo each other. So that leaves me with x equals 25 over 2. So in this video, we took a look at inverse operations, how addition and subtraction undo each other, how multiplication and division undo each other, and how squaring and taking the square root of something undo each other.